Hello everyone, this is Yinjun from University of Pennsylvania. Today I'm very happy to be here to present my recent work that is Shift, a cheap and fast pipeline for iteratively cleaning label uncertainties. This is a joint work with Dr. James Weimer and Dr. Susan B. Davidson. So first of all, we will know that in order to learn a good machine learning model, it's essential to have a large amount of training samples, which are all labeled. However, it's very difficult to obtain such kind of training dataset for many scientific domains, like the medical domain, because in those domains, labeling the training samples typically involve the efforts from the domain experts, and asking the domain experts to label large amount of training samples can be very time-consuming and expensive. Therefore, we need to figure out how we can learn a good machine learning model on this kind of training dataset in which only small amount of training samples are labeled. So to address such label sparsity problem, we can consider using the weakly supervised learning method. Specifically, we can use Snorkel, which can automatically produce the probabilistic labels on those unlabeled training samples. After that, we can train a machine learning model by using all of those training samples in the model constructor. But sometimes the users may not be happy about the performance of the resulting models. Therefore, to improve the label quality, we can ask the human annotators to clean the labels for some training samples with probabilistic labels. But we notice that sometimes the human annotators can make some mistakes on providing such clean labels. So to reduce such human annotation errors, we can have more than one human annotators such that we can aggregate the labels from those different human annotators. So for example, here we can have 3 different human annotators. To further determine which training samples should be cleaned by the human annotators, we typically need to have one component called the sample selector. And after the human annotators clean the labels for the samples identified by the sample selector, we can move forward to update the models in the model constructor by using the updated training dataset. So this label cleaning process can be repeated for multiple times until the model performance is good enough. So this label cleaning process has been used in many applications, but we found that it can be further improved by using our solution Shift. In Shift, first of all, we proposed a method called info to find out which training samples should be cleaned by the human annotators in the sample selector. After that, we proposed a method called Increm-Infl to reduce the overhead of using info in the sample selector. After that, we proposed a method called DeltaGrad-L in the model constructor to incrementally update the models after the human annotators clean the labels for some training samples. In the end, we proposed to redesign the entire label cleaning pipeline such that we can gain more benefits. So note that in Shift, we actually utilize some database techniques like the idea of incremental computations, which is a popular technique in the database domain. One such example is the solutions to incrementally update the database views, which can be dealt with by using data problems. And actually, data problems is also used in Shift. Then let me present the details of Shift. First of all, let us take a look at info, which can select the most influential training samples to be cleaned by the human annotators. But to find out such most influential training samples, we proposed to use a modified influence function to evaluate the influence of each training sample for a machine learning model. Specifically, to evaluate the influence of each training sample Z, we need to estimate how much the model prediction performance can be changed after the probabilistic label of this training sample is perturbed to some deterministic label. And then we can find out one deterministic label that can maximize the training sample influence for this training sample. And such label is called the possibly clean label, which can be regarded as the label provided by one additional labeler. So because of this one additional labeler, we can further reduce the number of the required human annotators by one, such that we can save the human annotation cost. We further did a lot of experiments which shows that info can outperform the baseline method in most cases. But we noticed that to use info for large training dataset is essential to overcome some efficiency issues. This is because when we use info to evaluate the training sample influence, one essential step is to calculate the gradients on each individual training sample, which can be very expensive, especially for large training dataset. But we notice that the label cleaning pipeline is an iterative pipeline. This indicates that the evaluation of the training sample influence by using info can also happen for multiple times. And we observe that in the next round, when we use info to evaluate the training sample influence again, those uninfluential training samples are highly likely to remain uninfluential. Then based on this observation, we proposed a method called Increm-Infl to filter out the majority of those uninfluential training samples by using some probabilistic information. And this can be done in a very efficient way. After that, we can use info to evaluate the influence on a small set of training samples. And in the end, we can obtain a set of the most influential training samples, which will be the same as the ones obtained without using Increm-Infl. Through our extensive experiments, we found that Increm-Infl can significantly accelerate the selections of the most influential training samples. We further proposed datagrad to speed up the model constructor. Recall that after the human annotators clean the labels for some training samples, we need to update the model in the model constructor. But we notice that the process of cleaning the labels for the most influential training samples can be regarded as two steps. That is, the deletions of those samples with probabilistic labels and the additions of those samples with cleaned labels. We notice that in the literature, there exists a lot of work that can incrementally update the machine learning models after such modifications on the training dataset. And one such example is DeltaGrad, which is a provenance-based solution to incrementally update the machine learning models. Therefore, we proposed a method called DeltaGrad-L, which is a modified version of DeltaGrad to achieve the incremental updates on the models in this kind of scenarios. And in the end, by using DeltaGrad-L, we can achieve significant speedups on updating the models by comparing to the way to retrain the model from scratch. In the end, we proposed to redesign the label cleaning pipeline to gain more benefits. Suppose we want the human annotators to clean the labels for 100 training samples in total. So instead of asking them to clean the labels for all of those 100 training samples provided by the sample selector, we can ask them to clean the labels for 10 training samples each time and repeat the entire label cleaning process for 10 times. And at each time, the sample selector can suggest which 10 training samples should be cleaned by those human annotators. In this way, we can achieve better overall model performance. In addition, we found that it's possible that at some point, the model performance is already good enough, even before the human annotators clean the labels for all the 100 training samples. So at that point, we can simply ask the human annotators to stop early without cleaning the labels for the remaining training samples. This can thus help us further save the human annotation cost. So in the end, let me quickly conclude. So in this work, we proposed a solution called Shift, which can improve the label cleaning pipeline from different perspectives. And in the future, we may want to take some practical concerns like the privacy concerns into consideration. And we also want to use a Shift in other framework like the semi-supervised learning framework. And that's all. Thanks.